Ladies and gentlemen, welcome to the following session. We are now, with pleasure, it's my pleasure to introduce Dr. De La Guardia, who is from University of Valencia, analytic chemistry. And, you know, people are very much afraid of chemicals here, there, and so on. So it's very useful to have some light about chemicals in vapor by somebody who is working with them all the time. Thank you.
Thank you very much. No, not before. Could be after. So many thanks for the organizers to invite me, and I will provide some data today. I will speak about the breath as a bioindicator of the passive and active smoker and vapors. So this is the presentation of some data of my student, Dr. Daniel Gallard, who works in the University of Valencia, and we have made several studies on vaping system by controlling the liquids and by making some measurements on the nicotine and many analytes you can find here. The subject of today will be focused on the use of low-cost portable gas sensors, which provide a very fast indication about the damage of the air, surrounding air when you are making smoking or vaping practices. So we have controlled both aspects by using this kind of portable sensors. And in this case, we have, well, this is really, I agree with you. This is not a perfect system, but I will try to focus. And we have controlled CO2 and CO, particulated materials, volatile organic compounds, and some other gases and vapors. By using these detectors, this is really low-cost system, less than 1,000 euros per system. And we have made the measurements in a 4 cubic meters room, closed room, controlling the indoor air and the breath of both active and passive smokers before and after the practice. So it could provide some ideas about the effect. And this is not a very fantastic analytical tool, obviously, but for comparative purposes it works. So this is an idea about the recording we are obtaining, so the different paths of smoking by producing the volatile organic compounds. This is some general detector, so in some cases you must be able about the nature of the surrounding area in order to prevent that there is some vapors which are not produced from the smoking or vaping practices can disturb your measurement. This is the reason for which we made some measurements before and after, and we compare the evolution of the system and the changes. So this is some of our results based on the consideration of traditional smoking practices. So in indoor air, we measure the average value plus minus standard deviation in the different units of the different compounds. We have measured in this case also formaldehyde, but this is a sensor which is not too much good. And so these results are not especially interesting. In the, sorry. I suffer the same illness than our French colleague. And in this case, only when you are measuring for the active smoker during smoking, you can observe some data which are higher than the limit of detection. But I am not so much sure that this is a correct evaluation of formaldehyde. So look at that and don't think that formaldehyde is terrible, dangerous. But look at that before and after, and regarding the indoor levels before to start the measurements. And you can look that, okay, this is an effect, and also when you are comparing the breath of passive smokers and active smokers, you can evaluate that there is some differences from the starting point of view, but especially after suffering the action of smoking inside the room. I am sure that these kind of results are important in order to evaluate the real existence of passive smoker and passive vapors. Because this is true. When you are in a free area, you are taking pure air. When you are inside a closed room and someone is smoking in front of you, you are taking some dirty air. But we must evaluate how much dirty is the air because you are suffering some practices or you are making yourself some practices. This is some kind of recordings monitoring the particulated matter, the CO2 and CO, and you can look that there is some variability. This is not perfectly stable system, but you can look at that there is some changes before and after, and it increased the level when we are controlling the smoking practice. When we consider the vaping practices, this is true that once again we must measure before and after. So in this, remember the previous results, we have changed because the stability and the quality of the air inside the room is not always the same, and this is the reason for which you are forced to do the experiments and refer to a baseline, which is the quality of air before starting. And in this case, we are measuring before vaping and during vaping. So you can look that for particulate materials, this is not exactly particulates, but some aerosols, which are controlled as a particulated materials. And also for CO2, CO, volatile organic compounds, and in this case formaldehyde. Once again, please, if you compare this data with the previous one, it is really, really small, but I am not so much sure that it is formaldehyde. But in this case, this is true that we have increase for the active people, but if you look at the passive vapors, there is nothing. So we are inside a closed room, and some of you are vaping. I am not aggressed as a passive vapor, because the amount that changes the composition of my breath, the quality of the air I have taken inside this room has not dramatically changed as compared with the action to be smoking in the room. So once again, you can look that for vapor, there is some changes, but in this case, the particulated material can change a little bit, and for CO2 and volatile organic compounds, it changed a little bit. But look at that. This is variability of the system, so we cannot think that, oh, this is tremendous effect. No, don't think about that. In last days, we have started measuring also another system. This is the heated not burn tobacco, and we have evaluated on using the same gas sensors, portable gas sensors. We have evaluated the quality of air inside the room and the active and passive smokers on this kind of tobacco. And once again, we have considered the orange and gold heat not burn tobacco and the sticks, and we have measured the volatile organic compound, the particulated material, the CO2, CO, and SO2. And look at that. This is the change in the air sampling before and after using the different systems. Also, the change in the active, the breath of active smoker and the breath or passive smoker. And once again, you can look that the changes are really, really small. This is true on reducing the temperature at which you are making the smoking practice. You are reducing the presence of some side compounds, and it can provide a reduced concentration of these gases in the air. So this is once again the recording, and this is true that it changed, but it changed in a very, very reduced scale, and you must take into account also the variability of the data. Imagine that the sensors, the gas portable sensors are working continuously, so it changed a little bit. On summarizing this data, you can look at the variation of volatile organic compounds, particulated materials, CO2 and CO, which are the most interesting data, because for this data, I am sure that my portable sensors works correctly, and look that the regular tobacco increases very high, obtains very high values of all the parameters considered in all the cases, except in the case of CO2 for our experiments. In the case of electronic cigarette, we obtain higher values than on using the other systems, but in this case, the variability was too much high. So you must repeat several times these measurements in order to provide a true statistic value. But when we are moving from this system to the, in the case of particulated material, we are moving from the regular tobacco to the non-burn tobacco. You can look that the e-cigarette and heated not burn provide a strong reduction of the levels. In this case, this is true that the reduction is higher on using heated not burn than on using vaping practices. And I have summarized that on this table in which we are comparing the average values of active exhaled breath and passive exhaled breath for regular tobacco, for electronic cigarette, and for the new tobacco from Philip Morris. And look at that, the situation of the vaping system is in the middle. So it is half the amount provided by regular tobacco, but in some cases higher. In the case of particulated material, really higher than the heat not burn. But what is the matter? In this case, when you are using the new tobacco, you are forced to consume a fixed amount of nicotine. In the case of the vaping practices, you, the vapor, you make the decision about the amount of nicotine you would like in your system. And so from my point of view, I am sure that we don't agree perfectly, and we will discuss, and especially after the dinner. Sometimes you need a big amount of nicotine, but if we are thinking to reduce not only to the harm effects of tobacco, but also some kind of dependence on the nicotine, I think that it is better to move for the vaping practices than to move to another kind of tobacco, which is more healthy, the traditional one, but fix your level. This is my suggestion to Philip Morris to also create some cigarettes with different amount of nicotine in order that you can select. And this is the key word for me. In the case of vaping, you selected the conditions, and this is your own decision. You are not dependent on the market. You can fill your system and dose the nicotine. And so this is a perfect system to avoid the side effects on your health of smoking practices, and at the same time to reduce the dependence on nicotine. I am sure that this is not when we are speaking in previous presentations about the moral effect. Moral is not the matter of philosophy, it's the matter of religion. And so I am not so much sure that we must criticize the use of many systems for the people if they don't damage the health of the other. This is perfect for me from a philosophical point of view. Religion is another question, and we can start speaking about nicotine, but also caffeine and theobromine and other molecules, and we can consider that it is very dangerous from the religious point of view or from the philosophical point of view. But looking at the lack of dependence of nicotine, vaping practices can assure you the way to modify that. Thank you very much for your attention, and I am open. Oh, thank you. Some questions.
Hello. Thank you very much. We're open to questions, but I'm going to ask people to be more succinct in the questions, because otherwise we are running short of time.
See, you're taking your role very seriously from the beginning. So I think that because we have some audience who are not experts in science, I think it's important to clarify that volatile organic compounds is a large group of chemicals, many of which are not harmful.
Yeah.
And the main reason, I think, why you found more volatile organic compounds in e-cigarettes than in IQOS and very close to the cigarette is that when you look at studies that have analyzed specifically each volatile organic compound, many of them are simply flavorings. Yes. Volatile organic compounds are also aldehydes. But with your system, you measure everything combined, so the total amount. But the vast majority of VOCs, as we call them in e-cigarettes, are flavoring compounds which are harmless. So when you see at VOCs, it doesn't necessarily mean that it's bad. There are some bad chemicals in there, but there are also some harmless chemicals which are also classified as VOCs. So the total amount is a combination of both. As for particles, you were very right. Most of the particles, it is still particles technically, but they are not solid particles. They are
aerosols.
Exactly. Aerosol means that it is micro droplets. It's not gas, so the term vapor in reality is wrong. The e-cigarette does not emit any vapor. Vapor means it's a gas state. The e-cigarettes emit an aerosol. The aerosol is not in a gas form. It's in a form of micro droplets. So you do evaporate the liquid inside the atomizer, but the vapor is immediately recondensed and forms these micro droplets. So these are also technically called particulate matter, but it's very different from the particulate matter that we discuss about environmental pollution, for example, where it is usually solid particles coming from combustion sources like car, exhausts, industry, and so on. So it is important to differentiate the composition, so basically both of VOCs and PEB, in order to understand the adverse effects, the potential adverse effects.
Yes, I perfectly agree with you in terms that this is a previous data to confirm the nature of the compounds emitted by the both passive and active. We need to pass through the gas chromatography and mass spectrometry system, obviously. But in this case, we are moving to another scale of cost, and the system are not always available for all the people. But obviously, you are right. And when we call VOCs, this is not toxic VOCs. This is general compounds which are volatilized inside the room.
I'd be very much interested in including in this study something to ground in the reality. Can you just include, for example, boiling water from pasta and assess VOC levels and then a fine characterization of by GCMS and whatever you feel it's appropriate? Because, I mean, this will anchor all this perception to the reality, and people will better understand, even politicians will better understand what we're talking about.
Yes, yes, you are right that, as for example, to boil water inside the room can provide an increase of the level of volatile compounds and also particulated materials like in the form of aerosols. This is true that we don't have measured that, but we will do on coming back to Valencia. That's a good idea. But we have made some measurements on burning aromatic sticks. Yes. So, and in this case, I assure you that also smoking practices are soft practices as compared with the data you can find on burning these sticks. And on cooking, but this is a practice. This is a traditional hippie practice to burn aromatic sticks. And it increases terribly the breath and the amount of CO2. And this is if you are working inside a small piece, it creates big troubles. This is true. We must focus on the reality. And this is one of the reasons for which to think that smoking people, vaping people are the devil. They make a big contamination. Okay, take your system and move to the car and to the bus. When the bus is passing in front of you, the quality of the air is worse than we are in open air than when you are moving to a closed room in which vaping practices are made. So I think that this bit of reality is very important in order to don't take decisions which can affect many, many people, regular people, and industrial activities and so on. Thank you to you.
So this is actually a follow-up to Ricardo's comment. The indoor air quality in an Anglican church has been measured to be not up to European air quality standards.
Yes.
Okay. This is because of candles and incense. And for just getting to the public understanding of the comparative risks, this is, I think, incredibly important. If we had the infographic that could show the particulates, the VOCs from smoking, the secondhand smoke,
Yeah.
vaping,
Yes.
candles, scented candles, incense, an open bottle of nail polish, all right, and compare that to outdoor air quality, this could help the public to understand.
Yes, you are right. Then we must use high-level tools in order to pass inside the molecules. But this is also a dangerous thing, because when you look for a molecule and you found that there is some level, people doesn't understand that this level is at the ultra trace level. And so you must evaluate that. This is the reason for which I love these comparative studies, in which you are comparing. And so you can measure the real danger of the some practices, instead of to provide absolute data. And absolute data could terrify because of the name of the molecule. You can be impressed. And this is not the matter.
People need to have the context. Yeah.
Watch my presentation afterwards if you're interested in that. Very good.
Yo animo a si alguien quiere preguntar en español.
Any further remarks in Spanish? My Spanish is better than my English. I have a sort of a strong Cuenca Spanish when I speak English, as you may realize. Well, that's your accent is better than my Tex-Mex accent. However, it's there is some fun about it anyway. Any further remarks? This not being the case, let's proceed. Otherwise, Anna might tell us off because we are running out of time. Thank you, Dr. De La Guardia.